Welcome to a new unit. This is Unit 2, Lesson 1, Part 1 of 2. Today we'll be talking about decimals, and you will understand why decimals are equal divisions of a whole. At the end of this lesson, you should know the vocabulary. You will know what a decimal is. You should know where the tenths, hundredths, and thousandths place are located on a decimal. Follow along with me as I read from the top. Fractions and decimals are special kinds of numbers. We are already familiar with fractions, and we know what those numbers are used for. They are used to show parts of a whole. Both of fractions and decimals tell the number of equal parts a whole is divided into, and the number of those parts that are being taken or described. In other words, a decimal will do the same thing as a fraction will do. It'll tell you how many pieces the whole is cut up into. Oftentimes I use pizza to represent that. And it will also tell you the number of pieces you have, which would be the numerator on a fraction. But we'll do this using whole numbers and a decimal. So let's get into it. On number 1 and number 2, they're basically just showing you some things that you are already familiar with. They're showing you have one whole. We can use this rectangular bar to represent one whole. We're going to take that whole and cut it into 4 equal pieces. That would require us to draw 3 lines. And when we do that, then each equal piece is going to be equal to 1/4. Each piece is 1/4 of the entire whole. It takes 4 pieces to make the whole thing. Number 2 represents an entire whole as well. But in this one, we're cutting this entire whole up into 5 equal pieces. That requires 4 lines to be drawn. That means that each piece now is of equal value, and each one is exactly 1/5 of the entire whole thing. If you were to shade 3 parts of this rectangular fraction bar, you would have 3/5 shaded. Each one of these represents 1/5. 1/5 plus 1/5 plus 1/5 is 3/5. This is how we show parts of a whole when we have less than a whole to show. We'll use sometimes fractions to show parts of that. We're familiar with that. And now we're going to move on to how we use decimals to show the exact same thing. Read along with me as I read the top part. Decimal notation uses a decimal point to show places to the right of the ones place. The tenths place shows one whole, such as $1, divided into 10 equal parts. Or the tenths place shows one whole, such as a pizza, divided into 10 equal parts. The hundredths place shows each tenth divided into 10 equal parts. Number 3's example, this looks more like a football field, but try to think of it like a pizza that's cut into 10 equal parts. So 1/10 of the pizza is shaded, and we represent that 1/10 with a fraction, 1/10. That shows 1 out of 10 equal parts. We're familiar with that. If we wanted to write 1/10 as a decimal, because the first digit to the right of the decimal, the one the arrow is pointing at right now, is the tenths place. That is tens with a TH. The tens place is on the other side of the decimal. It's over here. Actually, it would be the next number. The ones place is the 0, taking the place of the ones place. There is no whole number here, so we're representing that with just a 0. Then we have the decimal and the tenths place. Well, the fraction that is shaded is 1/10 with a TH. Therefore, we need to put a 1 in the tenths place on our decimal. And because there's nothing in the hundredths place, we are representing that with a 0. If we were trying to represent money, we would have to have the 0 because this is what 10 cents looks like. $0, 10 cents. If we didn't need to represent money, we wouldn't have to put the second 0 because this is the amount of pennies you have. You can't have just 1 penny in the tenths place and then nothing after it. But if we're not representing money, no $sign on this number, we're just representing 1/10, which could just mean 1/10 of your pizza up here. then we do not need the 0 at the end. If it's not money and there's zeros at the end of the decimal, we don't need those. This still reads as 1/10 because there is a 1 in the tenths place. Now let's take a look at number 4. Number 4, we have 100 pennies. 1 is shaded. Therefore, we have 1/100th shaded. So, if we have 1/100th shaded, we could write that a couple of different ways. Since it's really money, and we want to represent 1 penny, which is what is shaded, 1 penny, we would write that just like this. We would have $0 with a decimal, 0 tens place. There's no tenths. We don't have 10 cents, so we don't have 1 dime. We only have 1 penny, so the 1 is going to show up in the hundredths place because it takes 100 pennies to make a dollar. We have 1 penny, so we're going to put that 1 penny in the hundredths place. If we weren't representing money, then what we have here is 1/100th. 1 shaded out of 100 is 1/100th. And we can see that written as a fraction right here, 1/100th. And since it's not money, it doesn't really change much here except for the dollar sign. But we still have 0 and 1/100th. 1 is in the hundredths place, so we would say what we see, which is the number 1, and the last place value that we see in our number is the hundredths place, so we'll say 1/100th. On example number 5, we still have 100 pennies. We've shaded 1 penny, but we've made a notation, they've made a notation, that this penny that they shaded isn't the entire penny being shaded, just 1/10 of that penny. So imagine breaking this penny up into 10 equal parts and only taking 1 part of that. 1/10 of a penny. If you broke each of these pennies into tenths, then you would have 1,000 places. So we're breaking this one into tenths, so theoretically we're breaking them all into tenths. So you can multiply this 100 times 10 and you'll get 1,000. So what we're talking about here is 1,000 pieces, each penny broken into 10 equal pieces to equal 1,000. If you do that, you could write your fraction 1/1000th. This would be how you write it. That's familiar to us. If it was money, you can't say, usually you wouldn't be able to say you have 1,000th of a penny, although that is possible to have, especially when you're dealing with things like the stock market. It's possible that you could buy something for 1/1000th of a penny on the market. Of course, you can't go into a store to do that, but this is how you would show 1/1000th of a penny. You have $0, 0 dimes, 0 pennies, but 1/1000th. 1/1000th of a penny shown right here. And if there is no money involved, that's not going to change the way the decimal looks, but it will change that there will be no dollar sign in front of it. This is how you say 1,000th without having it equal to money. Now I want to go back up to the top paragraph again and reread that for comprehension purposes. I think this will make more sense to you now. Decimal notation, otherwise known as just decimals, uses a point, that would be this dot, this decimal, to show places to the right of the ones place. This is where we're talking about when we're talking about decimals, to the right of the ones place. The tenths, hundreds, and thousands. The tenths place shows 1 whole divided into 10 equal parts. It would be like writing a fraction, 1/10. That's showing 1 whole cut into 10 equal parts, and you have 1 piece. 2/10 is a whole cut into 10 equal parts, you have 2 pieces. 3/10, a whole cut into 10 equal parts, but you have 3 pieces. The hundredths place shows each tenth divided into 10 equal parts. And you can see that right here where we took the exact same fraction bar cut into 10 equal parts, and we took, instead of having 1 penny in this first part, we broke this penny up here into 10 equal parts. And now we have 100 total. It's a 10, like one of these dimes over here, but cut up into 10 extra equal pieces. So 10 cut into 10 pieces each time is going to equal up to 100. Now you have 100 pieces. So the hundredths place is really just showing a tenth cut up into or divided into 10 equal parts. And a thousandth is basically following the same pattern. Now it's going to take 100 and divide that into 10 equal parts as well. I set up a place value chart here to show you the patterns. If we have the same number in every place value, we can start to see a pattern develop as we go from the ones place to the tens place to the hundreds place. We have two ones here, but as we go to the tens place, the value of the two becomes more. It becomes worth 20 because it's two tens, which is worth 20. 20 is exactly 10 times as much as 2. Going from the ones to the tens place is really multiplying by 10. The value of the digit goes up by 10. As we go from the tens to the hundreds place, the tens, remember the 2 was worth 20, but in the hundreds place, the 2 is worth 200. How do you go from 20 to 200? Multiply by 10. You'll see that going from the ones place to the tens place is increasing by 10. From the tens to the hundreds increases by 10 as well. And you will continue to follow that pattern, and you will increase by 10 when you go from the hundreds place to the thousands place. From the thousands to the 10,000s place is multiplying by 10 as well. Every time you go this direction from the decimal point, you're going to be increasing the value, or the place value increases by 10. By the way, the decimal, when we do see a decimal or read a decimal, we use the word and to represent that decimal. So everything to the right of the decimal is going to be exactly the opposite. Even when memorizing tenths, hundreds, thousandths, you can think of them as the opposite of the other side. If you notice, the tenths place is very similar to the tens place, except the difference is that it has a th at the end. That's important. You need to have the th when you're reading decimals. Also notice that there is no oneths. We have a ones place on this side of the decimal, but we do not have one on this side. If you can just remember that this side is a mirror image of this side after you cover up the ones place. You must cover this up, and then both sides are mirror images of each other. Because we have the tens here, the tenths. We have the hundreds here, we have the hundredths. We have the thousands next to it, we have the thousandths. We'll have the 10,000s, then we'll come over here, and the very next decimal will be the 10,000s. That will continue to go forever. And as you start from the and, or from the decimal, as you start going from the decimal, the first number or place value is tenths. What this means, this tenths place, if we went back to the worksheet, it means take your whole number and divide it by 10. Going from the ones place to the tenths place is dividing by 10. A tenth is exactly 1 divided by 10. We could write 2/10 as a fraction, and we can write 2 whole as a whole number. And if we divide 2 whole by 10, we will get 2/10. So going from the ones place to the tens place, we're dividing by 10, or we're just doing the opposite. Notice when we were multiplying by 10 over here, we're going from right to left. If we were going to do the opposite and go from left to right, then we're dividing by 10. We're doing the opposite. And that's what we're doing here. We're going to go from the tenths to the hundreds, and the hundreds place basically is a tenth of the tenths place. We're going to divide by 10 again, meaning that the hundreds place is smaller than the tenths place. If you have 1/100th, you don't have as much as if you have 1/10. And going from the hundreds place to the thousands place is also dividing by 10. And the reason why is because we're going this direction from left to right. Going from left to right is divide by 10 every place value. Going from right to left is multiply by 10. each place value. Going one direction is multiply, the other direction is dividing. So let's start with a whole number 4. And let's now see what would happen if we divided 4 by 10. If we went this direction and divided 4 by 10, 4 divided by 10. Remember that this fraction problems are also division problems. Now, let's read the number. If we're going to take our whole number 4 and we were to divide that by 10, we would have 4/10. This is how you write 4/10. So really, we're getting 4/10 over here by dividing our whole number by 10. So it's 10 times less than the ones place. If we were to take our 4/10 and divide it by 10 again, we would end up with 4/100. Here's 4/10 divided by 10, which is the same thing as 4/10 times 1/10, which equals 4/100. We would write 4/100 by putting a 4 in the hundredths place. Now let's see if we had started with 4/100 and we divided 4/100 by 10 again, we would end up with 4,000. 4/100 divided by 10 is the same as times 1/10. We'll get you 4/1000. There is proof that as you go from left to right, each time you go from one place value to the next, from left to right, each place value is showing you 10 times less than the one to the left was. As you go the opposite direction, as you go from right to left, each place value is increasing by 10. So you're either increasing by 10 or decreasing by 10, depending on which direction you go.